So what we're going to do now is we're going to evaluate the condition of the main bearing bores on this engine block. We're going to use the dial bore gauge that has the retractable head on it. It is accurate to within 1/10 of a thousandth. This dial has this lever here which allows it to compress, and that, as I push in on the lever, you can see the little wheels down here compress. And the purpose for that is so that as I manipulate the dial through the different main bearing bores on this block, I'll be able to hold it at a position like this, collapse the rollers, it won't fight you all the way through. This screw here, as I tighten it up, increases the tension on the rollers. And these rollers are spring loaded. If you have them too loose, what will happen is when you're trying to take a measurement on the sideways, this here will fall. And we don't want it to fall. We're already going to have to support it with our finger. But if this thing is too loose, it will just simply, you put it in there and it falls down and doesn't stay in the middle where it's supposed to. We've set it up for 5 inches and 535 thousandths, I believe. The dial bore gauge is going to tell us if this bore is larger or smaller than our targeted size. So what I'm going to do is put the dial bore gauge in here, and I notice that I got the foot towards the edge, and I'm going to rock the dial up and down, and it says that I'm 1/1000th larger than my targeted size. Okay, as I move it to the middle, I'm 1,003/10 larger. As I move it to the other side, I'm 1,000th and a half larger. So what that just told me is that this main bearing cap is actually leaning towards us. There might be a piece of dirt underneath the cap. The caps need to be torqued down to spec. It needs to be the correct cap for this location. Each cap is numbered 1 through 7 in this situation. It needs to be oriented in the right direction, and it needs to be torqued correctly. If any of those things are wrong, you're going to end up with wrong sizes or measurements that are way out of spec. And on the other side back here, I'm using my finger to keep it from falling off. There I'm 1,000th and a half. The next thing I'm going to do is I'm going to check this bore for outer round. I'm going to do that by measuring it in the middle, which the size is 1 2/10 larger than my targeted size. Then I'm going to collapse it with my finger, rotate it to where the gauge point is on the lower side of the parting line, and my reading, this thing is going to be on the top side of the line. Now I'm going to stick my finger in the back here, and I'm going to kind of support it. If I don't support it, what will happen is this thing will fall a little bit and I'll get inaccurate numbers. So I'm going to put it in place, support it with my finger, and then I'm going to bring it out until it changes directions. As I bring it out, I'm reading 1/2 thousandths larger than what my targeted size was, so plus 1/2. Now I'm going to let go with my finger and watch what happens to the dial. See how the dial got way smaller? If I lift it back up again, see how I can make it change directions with my finger just by raising it up and lowering it. I'm taking my finger and I'm pushing it against the block and supporting this base of this dial indicator so it can't fall. Okay, so I'm supporting it right there, and at that point now I'm going to rock it back and forth the other direction. So I'm plus 1/2 thousandths right there. So I've moved to the other side of the parting line. Again, I'm supporting it with my finger, and I'm going to rock it back and forth. Okay, this one says plus 2.5 thousandths. Now keep in mind, I was just plus 1/2 thousandths in the other direction. And here I'm at 2.5. So I go back to here again, I'm at plus 1/2. And if I go straight up and down, I'm plus 1 2/10. So before I send this block out to be remachined, I would want to check all of those things. Clean, no burrs, anything of the sort. under the cap. I want to make sure that it's torqued to spec, and I want to make sure that the cap is oriented correctly, meaning that it's in the right position this way, and it's in the right position, it's not turned 180 degrees off. What are called the bearing tangs, they're going to be right inside. In fact, I can show you in this connecting rod bore. You can see in here that there's bearing tangs. Notice that the bottom of the cap has a bearing tang, and also the rod has a bearing tang. The rule is that the bearing tangs always go together. So if the cap was on incorrectly, I possibly would have this bearing tang would be on that side, and this bearing tang would be on the opposite side. That would tell me that the cap was oriented wrong. The caps will have numbers on it. Now, this cap right on the top says number, looks like a number 4 or 5. That would probably explain why our numbers are off by so far. The caps are numbered starting at the front of the block to the rear, numbers 1 through 7. And so if someone put the wrong cap in the wrong spot, then I would get numbers like what my dial bore gauge showed me. If I was to put the engine together in this condition, the main bearing, because of its lack of clearance, would literally bind up and cause the bearing to start to spin in the bore on the crankshaft, and I'd end up with a failed crankshaft and bearing almost immediately.